A particle moves along the x-axis so that at any time t is greater than or equal to 0, its velocity is given by cosine of 2 minus t squared. The position of the particle is 3 at time t is equal to 0. What is the position of the particle when its velocity is first equal to 0? So let's first write the equation for the position function, because that's what we ultimately going to need. So x of t is equal to the initial position plus the integral from 0 to t of the velocity function. Okay, so this is the equation for the position function. So now take a look at this. We're going to use velocity function because it's given to us that the position of the particle is 3 at time t is equal to 0. But the velocity calls for actually using this part. Velocity is first equal to 0. So first we need to find the time. We need to find the t value at which the velocity is equal to 0. So what we want to do, let's write the velocity function. This is given to us as 2 minus t squared, cosine of 2 minus t squared. We want to set that to 0 because that's what's being required, right? We need to find the time at which the velocity is first equal to 0 because we're going to need that time, the t value, in order to plug this into the position function. All right, so we're going to set that to 0 is equal to cosine of 2 minus t squared. Now notice the following. Notice that the cosine function is, so it calls for the cosine function to be 0. And we know the cosine is 0 whenever the angle is pi over 2. So we want to set the angle inside the parentheses to pi over 2, equal to pi over 2. So essentially pi over 2 is equal to 2 minus t squared. So now we can find the value of t at which the velocity is first equal to 0. And notice it says is first equal to 0. Right? That should tell you that the first time the cosine function is 0 when the angle is pi over 2. Right? That will tell you that not to use any other angles. Whenever, let's say 3 pi over 2, right? You're not going to use that because it says first equal to 0. First, right? Cosine is first equal to 0 when the angle is pi over 2. Right. So now solving for t should be fairly easy. It's just algebra. You know that the t squared, basically if you subtract pi over 2 on both sides, and then of course if you add t squared on both sides, this should solve for t squared. So t squared would be what? That would be 2 minus pi over 2. And of course the positive t version is useful only because the time is counted forward. So the t value is going to be just positive square root of 2 minus pi over 2. Beautiful. So now that we found the t value, we can actually plug this into the upper limit of the integral, right? And then we're going to find the position at that t value. So essentially what we want to do now, we know that x of 0 is equal to 3, right? So we're going to basically substitute this part with 3. All right, so x of square root of 2 minus pi over 2. And again, why am I plugging this? This is the t value that we found, right? At which the velocity is first equal to 0. Right? Because it says what is the position at that time, right? So that's why I'm plugging this into the position function, the time at which the velocity is first equal to 0. So that's going to be the initial position, which is 3. So we're substituting that in. I'm using this equation right now that it involves the integral. So 3 plus from 0, integral from 0 to the time that we just found at which the velocity is first equal to 0. And the velocity function, of course, is cosine of 2 minus t squared dt. Now, this integral cannot be done by hand, so you will need a calculator for this. The calculator that does integrals, or online calculator, whatever it is that you want. But basically what it's going to be is 3 plus, and the integral value should be approximately negative 0.184. Okay, so this part is approximately negative 0.184. That's what the calculator should give you. Okay, so if you do this correctly, you're looking at 3 minus 0.184, which is equal to 2.816 precisely. So the correct answer that you should indicate is C. Thank you so much for watching. Hope this was helpful. See you in the next video.